Hi, Professor Kane. It's Chad McCoy. I'm here today to present my Sustaining Bee Populations through UAS Applications paper for you. So let's get started. So we're going to go through a introduction, then we'll get into the UAS elements of human operators, the payload design elements, aircraft type, and then into the pollination methods, and finally a conclusion. So when I started this, I thought, well, what is the importance of bees in our world? And there are a couple of things that have been happening that make bees really important. One thing is bees are tied to the world food supply. And a couple statistics from that, the US Department of Agriculture says 35% of food crops and 75% of the world's flowering plants depend on bees and other pollinators. And we've seen a big decline in the population of bees. So we have seen a loss over the years. And they're not sure exactly how much, but they've seen a decline and they're relating that decline to a variety of factors: pesticide exposure, climate change, contagious diseases. But they've said one thing they're all in common with is that they all are tied to intensive agriculture, modern intensive agriculture. So the purpose of my paper is really to look at UAS and how it can help with sustaining bee populations, with the focus mainly on the UAS elements of human operators, specialized payload design, aircraft type, and then the pollination methods that we'll discuss. So the first element being UAS human operators. What I found is in this environment, I think a human operator is the best approach. And the operator would have to have specialized UAS training to navigate really to various locations. Then you have to understand the bees. So that requires knowledge of bee behavior, the way bees migrate, they move. You can have to be aware of tracking bee movements, how you can keep a healthy hive, a variety of knowledge in that arena. Then there's always the ethical and environmental considerations, which a human, in my opinion, is the best for that. Can make those decisions, make sure they're doing the ethical thing, and make sure they're not inadvertently impacting the environment in a negative way. The next element being payload design. This one is you could do a variety of things, but I think based on what I've found is there are a couple of different approaches. Definitely high resolution cameras and sensors can be helpful with the payload if you're looking to do conditions of the hive and a monitoring of those conditions over time. The bee migration patterns would be something easily tracked with those items. Identify potential threats of hives and other things that could be impacting the bees. And then you can get into the spraying mechanisms when it comes to the pollination piece. And that would allow for the pollination in addition to not just pollination, but you could also incorporate nutritional supplements, pesticides in the spraying, and other type of items to help support the bee health as well. And then you have the weight and power requirements of the drone. Depending on the mission, of course, you have to find what's going to work the best. This is just a picture here of the actual XAG, one of their plant series drones that they use. And then finally, the environmental impact is always important to make sure what you're spraying or what you're doing to the environment is not causing a negative impact. The next element being aircraft type. I found in the research that fixed wing is an option if you wanted to consider large scale monitoring and data collection. That would be primary for that. But when I focused on the pollination piece, I found that VTOL quadcopters look to be the best option in that scenario. This is a picture of the XAG P series UAS, which has been used in pollination, and we'll get to those examples soon. But they seem to be the best approach because they are versatile, they're agile, and they can do those precision tasks in some pretty challenging areas and terrain. So the fun part of this, in my opinion, was seeing how these drones can actually pollinate and make a difference. So again, this is a picture of the XAGP series in the process of pollinating some trees. The examples I found were in Australia, pollination of almond trees, and in China, with pear trees. And in Australia, I didn't realize almond production is a vital segment of their economy, with nearly 100% of all the almond trees relying on bees for cross-pollination. So it's a pretty important industry. They have seen decreasing yields, which is what has come up, which is why they went to this option to see if it could make a difference. And they did find that spraying the pollen liquid via the drones increased yields by 15%. And in China, the pear trees, they actually were forced to find another option because they found that they required 150,000 bee colonies to do the pollination, and they were only able to get like 35,000. So the actual local government, to protect the bee colonies they had, stopped pollination by the bee colonies and forced it to be done by hand, which is labor intensive. So that then created the opportunity for an alternative, which was the drone pollination. An interesting fact on this one I found was they coordinated, or not coordinated, they collaborated with the Corla Fragrant Pear Research Center to come up with a solution in the pollen liquid that they created. Not only did it pollinate, but it had a nutrient involved to help with the period of the blossoms and increase the pollination rate. So very interesting in that aspect. Just a couple interesting notes on the hand pollination versus the drone pollination. The hand pollination could only complete a quarter of an acre a day with a cost of $400 per 2.5 acres that were completed. The drone pollination could complete 30 acres a day with a cost of $52 per 2.5 acres. So pretty significant change there for sure. The second one I looked at was a Japanese researcher at Japan's National Institute of Advanced Industrial Science and Technology, Ahiro Miyako. He did a drone prototype, an insect-sized drone prototype, which there are a couple pictures here. One is an artist rendering showing how small it is to get into a flower, and the other is the actual prototype flipped upside down. Excuse me. And as you see on the prototype upside down, they've used horsehair to mimic the fuzzy exterior of bees and within that, they provide an electric charge to keep the grains attached. So they wanted it to actually truly be like a bee drone. Excuse me, the cost of the commercial drone is like $100, so fairly inexpensive. It hasn't been fully tested, so there is skepticism due to the remote control of type drone and that they are difficult to maneuver into those small places. The researcher did say future prototypes are probably on the table where they can hopefully incorporate some AI, some GPS, and some high resolution camera on it to help it become more of a reality. And finally, in conclusion, when looking at the UAS and the elements of UAS, you have to have careful consideration to make sure you're meeting the mission objectives. We've highlighted human operator, the specialized payload design, the aircraft type are all important, but you have to really look at everything specialized to make sure you're meeting the mission objective. Collaboration is also very important. Between the people who are technology savvy, the technologists, the ecologists, and the beekeepers, there has to be collaboration and coordination to make sure this is going to work and help sustain the bee population. And we talked about ethical and environmental impacts. Again, very important when you're dealing with bees and the ecology. You have to make sure you're making the right decisions to not negatively impact the environment. And as we've shown and seen, there has been a positive impact on bee conservation due to the UAS and the different applications that have been created. It is going to require ongoing research and development just to make sure that impact is continuing and to make sure it's maximized. Last page is just my sources cited for you. And that completes the presentation. Thank you.